Hello friends, good morning, good afternoon, and good evening. So in my previous session, we talked on the CAN login, how we can go for the CAN login, and then how we can analyze the CAN logged data. So the two sessions I have covered on this CAN log topic. And the third one, which is very important, that is CAN log data exports. So once you log the data, you do the analysis on that logged file. And if you do the analysis, and if you want to export that data into different file format, that topic is actually it's a CANlog data exports. In today's session, we're going to talk more in detail. What are the different export options and what are the different settings which you need to know before you going for exporting the files in different file formats. In the previous session, we talked more on the different logging file formats, CSV, MAT file, MDF file, XML file. I have 4 file formats, so different file formats. With the help of analysis, CANlog analysis session, we talked on how we can do the analysis in the offline mode. And if you have a specific file format, how you can export that file format from one file format to the other file format. And this is what I'm gonna cover today. What is my plan today? I will start with the introduction. So basically introduction is nothing but what we have covered in so far and what is today's plan. That's all about the introduction part. What are the major topic today I'm gonna cover? It's export and login settings. What are the different settings? Very widely used and frequently used file formats are CSV and MAT file formats. What are the different settings being used under the CSV file settings and for the MAT file settings? Then we will go for selecting the signals because when you export the data and want to convert from one file format to other file format, you must be interested in those few specific signals. Then how you can select the signals that we will see. And very important, when you export the file, how you can use that file in the Excel as well as in the MATLAB. That's very important. These two tools are the methods being widely used to do the analysis as well as do the um, some statistics around your exported data. And that we will see everything through the live example. So this is my today's plan. So let's start with the learning today. So, okay. So when you open your CANalyzer tool, this is how the window looks. And I have covered thoroughly about the basics of the CANalyzer. And also I talked on the last session on the login. What are the different use cases of this analysis windows? What is the CAN statistics window, trace window, as well as I covered the DTC monitoring window, data window, graphics window, everything I have covered in the previous session. Now we are jumping on exporting. So the export option comes on this login. If I right click here, you see this is the disabled at the moment. The reason for disabling is you have not added the source file yet, the file which you want to export. So let's start with that. Before going for the export file, it is very important. If you know you have captured the log file from the CAN channel 1 or the CAN channel 2 on the vehicle, it is very important to know what are the different ECUs are connected to that network. Why you need that information? Because if you know the signal or the message which you want to export, you should know or you should have the database file regarding to that specific CAN network or the ECUs connected into that CAN network. So the first step for exporting the file is adding the CAN database file. So what I will do, I'll come here and then I will add the database file. So just right click and start adding your database files. So I know I have to work around some inverters. So I will add that database file. And I know all the information of the database file was captured or the log file which I'm gonna use for exporting all that information present on the CAN one. That's what I added that database file on the channel one. If you are not aware of that, you can do one thing. You can add the database file on both CAN channel. Now This is the first step you need to follow. And then again, you need to go to select the source file. Where you can select the source file, here you can select the source file. So for that, you need to go for the offline. Now I shifted to the offline mode. We don't need online mode. And then I will add my source file. Means the file which I wanted to export into the different file format. Now here is the option where you can directly add, or here you can right click and the add offline source. So I'm gonna add. So I'm interested in this file. So I added this log file. It is done. Now what I will do, now let's see whether the export option is available or not. Still that export option is not available. And the reason for the option is not available is you added the source file, but this file is not through this um, branch that signals or the messages are not reached to the analysis window. So this part is basically analysis window. This part is online, and this is the offline mode where you have loaded your source file. This is what you need to do. You need to run this simulation or run this setup. So now what I will do, I will run this. I will jump here and I can see here all the messages are present into the network, right? That means now I have, but still this export option is not enabled. Then in that case, in the few of the CANalyzer and the CANoe options, the export options get enabled. Once you run the log file and all that messages reach to the analysis branches or the analysis windows, but in some cases it won't or it doesn't. So in that case, you need to just enable this um, hotspot and you need to override the file with any name. So let it be with the name of, let's say, sample login. So I will just say the sample login. Okay. And now I will just override with these messages. Now the messages are overwritten. Then just right click on this and you see this export option is available. We covered in the last session on the login file configuration option. This is just opening the folder and this is just adding the files into the offline source. And this is how your export option is now enabled. Now what I will do now, I'll go to the export. You see here, already the source file is picked up. What you have to do, you just have to select the destination file. Selecting the destination file means here you need to select the options. Okay, so how you can select the options? So let's go one by one. So I'm gonna just adding this. Let me come here. What I gonna do? I'm gonna just select the destination folder. So I will select this destination folder. But before selecting the destination folder, basically it asks for the type of the file you want to convert. If I say I want to convert the CSV, then you need to select the CSV. If you want to convert into MAT file, you need to select the MAT. Okay, so accordingly, you have to select your options. So let's start with the CSV file. And here I'm saying just a sample file. Okay, so this is the name of my file, which I'm gonna convert actually. So let's say I'm saving this, and then I will go for the different settings. What are that different settings are and what is their meaning is basically. So here you can see all the signal informations. Okay, and okay, so you can see here all. You can go through the help if you want more in detail about all these options. And here, very important is the signal information. Here you can see all the signals. If you export here, and then there is a setting that is the advanced setting. At the moment, I don't want to go for exporting the signals. So before jumping for exporting the signal, let's go to the advanced settings. Okay, so I'll come here, I'll just hit on the settings. And this is basically the majorly important where you can set export, and the logging settings. So what is this signal format, variable format? We will see now. So when I say format, there are two formats, signal format and a variable format. There are three options: name, message name, database name, and namespace name. So very simple. As the name indicate, the way it is given here, the way it is written here, when I say signal format, basically it is used to choose whether a signal name should be supplementally qualified and saved with the name of its associated message and the database file. Now, if I just want to save the signal name, then I have to click on this option. If I want um, my signal should be stored or exported with the name of the message along with the signal name, then you have to select this option. And if you are interested along with the database file name and the message along with the signal name, then you select this option. So I'm keeping on the third option as it was a default option there. This variable name format or the variable format option, basically, this allows you to choose whether the variable name should be supplementary qualified and saved with the name of its database file. If you are interested for saving the variable in terms of the format along with its database, then you need to select accordingly. If you want only name, if you want the namespace along with the name of the variable, select this option. So let it be the default. Then the next option is a delimiter. So this field allow you to choose whether the variable, uh, this field actually specifies the separator, which is used between the individual parts of the qualified signals or the variables. And here you can enter up to the 3 characters. The blank character is also considered. Here you can enter, and by default, it is 2 colons are there. So let it be, don't touch that. And we are not interested here actually. And the third major area is a signal value. So when I say signal value, there are 3 types. One is a write raw value. Then second option is a write symbolic value. And third option is a save J1 and 39 signal with invalid values. When I enable this checkbox with the write raw value, that means it specifies here whether the signal raw value should be output when exporting. Okay. And I have explained very well what is the raw value and what is the physical value. We always not interested in the raw value. We always interested in the physical value. So don't enable this checkbox basically. So this setting has no effect when exporting from the graphics windows, since in such case, the graphics window setting is used. Whatever the setting you use in the graphics window, the same is applicable. So these settings are not applicable in case if you are using the shortest way to export the file with the help of the graphics window. And that I will explain, I will show you while having the live demo. Second option is a write symbolic value, and third option is here. When you enable this checkbox, you determine whether the invalid values for the J1N signals shall be exported. You can easily determine. If deactivated, invalid values will be ignored and not exported. So this option is only relevant for the export. The source file must be loaded again to consider the changed option correctly. So I'm just letting these options as it is, and this is important. Always my recommendation is please select the data base, message and name format, signal format. And for the variable format, if you are more interested with the namespace along with the variable name, then my suggestion is please go ahead with this. But for the signal format, strong recommendation either to select the message or the database message and the name, because it gives you clear indication what that signal is coming from. Because in the J1 and 39, the vehicle speed can be broadcasted by instrument cluster as well as can be broadcasted by ABS or the EBS braking system. So in that case, you must be aware of that. Who is actually sending that message? If you just select the name of the signal, then you may get confused. So message will help you as well as the database message name will help you. So this format is applicable for all settings: ASCII settings, CSV settings, MAT setting, MDF, XML, and all. Now, very important is when you export any of the CAN log, we have selected the source file, that is the BLF file. And let me show you again here. If I close this option and if I double click on this, you see here the format is a BLF. Okay, so if I come here in the export option and if I go to the settings, um, you see here that BLF file can be exported into the ASCII, CSV, MAT, MDF, or any other file formats, which you can see here when you save the destination. So here you can see, you can convert into MDF, MF4, IMG, OP2, PCAP, whatever the format which required for you. But the settings and that setting basically are very important. What that settings are, it start with the format, how you want to export, and settings are not given for the MF4 file, not given for MDF file. It is morely given for the ASCII, CSV, MAT, MDF, and XML file. Very important because it is required. Nowadays, today, if you ask me, the widely used file formats are CSV and the MAT, and that is what I'm gonna cover. I will not cover here on the MDF and the XML file format, but I will talk on this CSV and the MAT in detail, and I will cover the demo around that. Now, why we use this MAT and CSV file format, try to understand why we export the files from the one file format to the other file format. If you are handling or using the CANalyzer tool or any KVSAR tool or any other CAN tool like Vehicle Spy, in that case, this BLF ASCII file formats are very well known to that tools. Or even if you are using the Inca tool, that file can be converted and used using the other tools. But just imagine if you don't have any CANalyzer tool or any CAN analysis tool, I would say, instead of saying the CAN analyzer, because it is a vectors tool, or CANoe tool is a vectors tool. If you are not with any CAN analyzing tool with you, in that case, um, you will end up with, I mean, you need to have the other way solution where you can analyze your data. So in that case, the MATLAB, which is a widely used simulation tool, or MATLAB, it's a laboratory basically. So MathWorks tool, you can export the file into the MATLAB and do the analysis or the statistics over there. The same with the CSV. When you export the file in CSV, it is commonly used. Excel is commonly available. You can use the signals over there, and then you can do the multiplication or any analysis or any um, uh, arithmetic operations with the help of Excel. The same way you can do in the MATLAB. You can plot the histograms. You can see how the signals are presenting over time. Everything is possible in CSV as well as in the MATLAB. That is the reason you export the file mostly in the CSV and in MAT file. Many times it has been exported into XML, but for the automotive domain, the CSV and the MAT are widely used because the MathWorks MATLAB tool commonly used, and it can be easily used for plotting the graphs. Look for the power consumption, energy consumption, plotting the histogram. Everything is possible in the MATLAB. And the same way, you can do statistics around calculating the average value, looking for the multiplication of the torque and speed to calculate the power. Everything can be done in this Excel. That is why my target for today to make you aware all the settings in the CSV and the MAT. So this is why we mostly focus on the CSV and this MAT setting. So let's go for jump to the CSV setting. Here, format tab is there, the time axis is there, and then the last one is a signal value. Very interesting. First is a comma separator. Here you specify the separator, and this is used when you are saving. Okay, how you are separating your um, your signals or your variables. This is how it is been used. And this is by default, it is a not a semicolon, it's a colon here. So you by default colon is used. Now the decimal symbol, and this decimal symbol specifies the decimal symbol that is used when saving the file. Okay, and when you want the decimal places, basically you can change, like I want after 5 places or I want after 6 places. That way you can change. And this is decimal places for the signal value. This is decimal places for the time. And if you enable this export global header with this option, you can select if the global header should also be saved in the file format or not. The header contains the application name, configuration name, date, and the time. So everything can be available during the export. But I'm not enabling this here at the moment. Let it be here. And then second option is a quote alt text cells. With this option, quotation marks are placed around all the text when saving. So numerical signal values remain unchanged, though you enable this checkbox. So I'm just letting this checkbox disabled. I'm not enabling it. Moving to the next, that is a time axis. Because when you export the signal, that signal has a time axis, and that is very important how you present that time axis. These options allows you how you want your time axis. When I say time axis for each signal, when I select this option, it creates for each signal a separate time axis. Imagine you want to export vehicle speed, throttle position, motor speed, motor torque, engine speed, engine torque. Every signal is a part of the message, and each message might have the different periodicity. So if you want to export that signals, you definitely need a different time axis. Okay, you can maybe expect the one-time axis. If you go for the one-time axis, that means all signals will get plotted along with this one-time axis. But how? Because this option is interlinked with this. Just understand on this. If I select the common time axis for all signal, that means um, you are selecting the option where you are selecting the one time axis for all the signals. And this is a third option, that is the calculate new common time axis. I want to decide my time interval. If you are confident that my lowest periodicity of my all can log is, let's say, 10 millisecond, and so if you don't want to lose the samples of each signal, then you can set the periodicity lesser than 10 millisecond, like saying I would say something around 5 millisecond or something. So let's say if it is 10, I will set this is a 5, let's say. So here I said it is a 5 millisecond now. That means, um, sorry, this is a 50 millisecond at the moment. So if I set this as a 5, that means now I set the 5 millisecond periodicity. That means I will not skip any signal, and I don't want to compromise on the signal, um, missing signal. So in that case, I need to um, keep this time interval very small. Okay. Now this option is interlinked with this options, because when I say export time related to the measurement start, that means um, this allows you to export the time relative to the measurement start. And this, when I say export absolute date and time, this option export the absolute time, whatever the time is today, along with all the details up to the seconds actually. So it's just standard time along with the date, year, month, everything is been can be along with the date, so it can be exported. So I'll keep this as a default, and I will explain you this time axis more in detail um, shortly. So if I and the next is a signal value basically. So what is the signal value is? When I say current value, that means it saves the current value. So you see here, I have selected the one-time axis for a signal. For that, I just only have the option that is the current value. Okay. If I select this common time axis for all signals, now it is allowing me current value, last value, next value. Okay. Because what I'm doing, I am commonizing the time axis for all signal. And if the all signals are in the different timestamp, what I want to interpolate that. Either I can keep the current value to be time stamped for each time sample, or I can either keep the last value, or I can keep the next value, or I can put the interpolation. And if I say one time axis, then there is no on options. It will just leave the blanks if the signal is not available for a particular timestamp. So if you want to understand this more in detail, let's have a look around this. So export for system, just in giving example for the system variables. And if we consider there are two signals, one is a pedal position and another is a car speed signal. Now what I have done in the first setting, if I keep this like one time axis for each signal, then I will end up with the conversion with these two tables. Like if I'm using the mat files, I would have the two mat files, or if if I am using the CSV file, then probably I would have the two, I mean, two columns, again, two columns, that means four columns. So one time axis for each signal. This is one signal and this is another signal. If I look for the periodicity for the pedal position, from this I can calculate the delta. It is approximately 270. It's not approximately, it is exactly 275 seconds. And here the story is like it is around um, 0.0495 is around 0. So it is approximately 0.05. That is what the seconds. So it is sure that the pedal position signal and this car speed signal are not with the same periodicity. And if I selected the one time axis for each signal, I have four columns. So it is a time relevant to measure measurement start, and um, uh, for each timestamp based on the current value, I can see the actual value of that specific signal. If I change the setting, if I go for the common time axis, now you see here, I have only one time axis, right? But what I have done, I have selected the other option, that time relative to the measurement start and the current signal value. So here, as I mentioned earlier, pedal position have a different periodicity and the car speed signal have a different periodicity. And I selected the current signal value. So it is just picking up the current values for this timestamp, and it is not doing any interpolation or extrapolation or even not padding of the value. So it is just keeping the blank because the pedal position value is not present for these samples. The periodicity for this signal is 0.275 seconds, right? So actually the signal is not available, the message is not available. So that's what it is keeping blank. I hope it is making sense and making it super clear. And if we go for the third option, and the third option is I would say, if I select the common time axis for all signal, let's say common time axis, but I want to go for selecting the different options for interpolation or extrapolation. So I just keep at the last signal value. If my last signal value is a 7, and though the signal is not present here, the last signal value gets stretched. Same story here, right? Same story here. So at this timestamp, I don't have a signal value, but the last value is stretched here. So this is how that options can help you. And why this is required, just imagine if I use this option, common time axis for all signal, time relevant for the measurement start and current signal value. And if I export this into the mat file, it will end up with the error. The reason, mat file basically generate the arrays in a MATLAB. You imagine the arrays with the blank space is possible? No, the answer is a big no. So that would end up with the error. So in that case, if we go for the mat file setting, definitely this option won't be there, and I will show you. This option is not there basically. So we need to have all the values. Either you can use the last value to be interpolated, or you can paired with this missing values with the last value, or the next value, or the current value, or you can interpolate, but you cannot keep this blank space. And this is possible in the CSV export. So this is how these settings are very important. Now, jumping back to this, let's jump for the mat settings. Now, so far, I guess it is very much clear on the CSV setting. This is a separator, which separates the signals. And let's go for the mat setting. Then I will show you actually exporting. We'll have the practical demonstration. So in the mat settings, if you compare uh, CSV setting and mat setting, here, here is the time axis, and these options are there, exporting the time, date, and all. And here also that options are there, but common time axis for all signal, that option is not here, right? And that's not possible, because if you keep the common, then you will end up with the error if the signal has the different periodicity. That's why that option is not there. But if I select my interpolation method or my timestamp here, then you can have this last value, next value, and this option is enabled. And this is the way, the same like one timestamp for each signal. Then this is user specific timestamp. And if you want to export the time related to measurement start, or if you want to export the date and time as well, then you can use this option. So I'm just keeping this as it is. So let's go for the CSV and let's check how it works. So before coming here, if you want to export your file in the CSV, you need to save your file with that name. So I need to save here, like I want to export in CSV, and I'm just giving the name as a sample export file. Okay, and I'm just hitting the save. Now you are done with your settings. Okay, I kept this colon as it is, and this is a decimal place, 6 and a decimal symbol. Okay, now I'm exporting. Okay, for that, what is the next step? You just have to extract. Hit on the extract, and here all signals will get populated. Now, if you are interested in the specific signal, just uncheck this. It will remove all the signal. And now go for your specific signal. Let's say I'm interested in speed and torque. Okay, so let's say, so I need to look for that signal. What is that? And where is the actual speed and torque? So let me look for speed and torque. Okay. Yeah, so here I'm saying this is the limit actually, but here is the speed, measured speed, let's say, and I have selected the measured speed. I can even go for voltage, current. So you need to checkbox, enable this checkbox. Then I will go for speed. So I have selected speed, current, okay, measured speed and measured. Already the speed is double from the inverter. Let's look for the torque. Then this is estimated sharp torque. Let's look for this torque. Okay, then let's see now what happens here. And okay, so okay, so now what I will do, I'll just hit on the save. What will happen in that case, based on the settings which we have set earlier, it will start exporting. Okay, now let's see how the file is exported. If I am interested to see the file, what I will do, I will just open that file. Now let's open that file and see. Okay. So here is the signal exported. How it is exported? This is an inverter speed, measured motor speed. Let me check the value here. Yeah, it is actual value. Then here is my time axis for inverter voltage. Then the time axis for speed again for the another signal, and this is a torque. Okay, let's see the torque value is actually, yeah, it is coming actual value. So this is how the separate time axis for each signal, right? So this timestamp and this timestamp is different, right? And this timestamp is different. Now I'm closing this file. I'm not saving this file, coming back and going for the settings. And if I change the setting here in the CSV, instead of one time axis, I want to go for the common time axis. Now let's see if I hit OK, and let's check the signals are selected and hit the save. It will ask for the override. Let it be. So let's see how it works. Same, it will work for the mat files also. So now let's open that file now. Okay, so file is saved. Now I'm opening the file. Okay, now let's see. Now, yeah, here you see the time axis is common. So 1, 2, 3. So we have 3 signals which we have exported, but you see here sample is missing. Here voltage sample is missing. Here speed sample is missing, and here the torque sample is missing. The reason, periodicity for these 2 messages are same, but periodicity for this message and this message, as well as for this message, is a different, right? So that's what it is missing, that it is not interpolated or not padded with any value. So let's look for that option as well. Once you are super clear on this, you will be clear on the next, on the mat file. So let's go for the setting. Then what I will do, I will, instead of going for current value, I will do the last value. Let's check what happens. Okay, then just hit on the save. So it will ask for the override. That's okay. I'm overriding, and let's open and check. Okay, so let's see. Let it be exported and saved. Now I'm ready. So file is ready. File is saved. Let's open it. It's opening. Now let's see. Now you see. Now do you see? The value is padded with the last. So there is no any blank space, and the time axis is common, right? So this is how the different setting works, and it is your need actually how you want to export your signal. Now let's also see for the last option, that is hit this option. If I wanted to go with this timestamp, I will hit OK, export, let it be override, and let's see. Now the timestamp is 5 milliseconds. So let's see how it looks. And now I'm opening the file. Yes, it is opening. So let's see. Okay. Here is a timestamp. You see here, the delta is 5 milliseconds. So this is how you can do the way you want, and value is also padded as per the settings. And the setting was like what I wanted to pad with the last value. You can select the next value, and even you can go for the interpolation. If the previous sample is 10, the next sample is 20, it will interpolate the value between 10 to 20 based on the timestamp which you want. So this is very simple. Now let's jump for the mat file. And this is again very interesting and common settings, which I think I have mostly covered on the mat format. But let's see again here, what are the different settings for the mat. Okay, the first on this mat is 1 minute. Okay, so we are starting with this. This is a signal name length. If you want the signal name length 31 character, 63 character, you can select. And why this is because MATLAB keeps the limitations. Basically, it won't allow you to go for and higher name of the signal, it throws an error. Basically, when I say the name of the signal, that name of the signal is a variable for the MATLAB when we export into the MATLAB. So this is how you want. Let it be a 19 character, and here it asks for the which version of the MATLAB. I'm keeping the default. Always remember, MATLAB is always supports the backward compatibility. So if you have the version higher than the 7.3, it will definitely help and it will work. And the 7.3 is older one, so definitely it will work. And all these settings I already have explained you. I'm keeping the timestamp this and keeping, let's say, do the interpolation and keep this and hit this OK. But before that, what you need to do, you need to select this destination file. So I'll come here and I'll select the mat file here. So let me do the mat, and then I'm keeping the same name, save, and already the signals are selected or no? Yeah, select signals are selected and just hit on the save. So it will save in the mat file. Now let's open the MATLAB and see how the file looks. Okay. Okay. So here is the MATLAB and here is the mat file saved. So just hit on that, double click on that, and these are all the variables are created inside the MATLAB. If you want to, I just loaded this mat file. It's a file with these different variables. If you see the size here, why the size for all is same? Because I set the timestamp based on my need actually, right? So that is the reason here everywhere you can see, let's open this. And if you see here, it is, I can see if I open the timestamp here, it's 100 millisecond, right? It's 100 millisecond, there's a delta. And so if you want to plot these, you can plot, use the plot, then time, and then which variable you want to plot. Let's say I want to plot this. I will drag here and just plot here. So let's see how the plot looks. So here is the plot, and here I can see this. This is a basically voltage. So inverter voltage with respect to the time, but this time is basically it is taken by actually, if you see here, you can see the interval samples basically. So it is taking the samples here. And if you want to name that, you can do anything here. You can plot histograms and everything that's possible. So that is the reason you bring all your file, mat file into the MATLAB, convert the MATLAB, and then you can do here. So everything is possible here in the MATLAB. So that's a different topic, and definitely I wanna cover on the MATLAB also. I'll start with the beginning and then I'll go to the little complex, and I'll definitely bring new topics in the MATLAB which you never find anywhere, and be would be very interesting for you, as well as would be the good in terms of the learnings. As well as there is a shortest way to export, and that shortest way is like if you select any of the signal here. If I come here in the graphics, and if I select add signals, and if I select the signals which I'm interested, let's say I'm interested in the torque or any speed value. Let's look for the torque and speed value, or even you can do one thing, you can just come here in here and you just export. If I'm interested in these two values, select that with the help of control, then even you can just copy this. Okay, let's copy. So let me show you again how you can do that. So I will come here, I will copy these signals, I will select these signals, copy, then I'll go back in the graphics, and then I will paste that signals here. Okay, so that's possible. Then one more thing is that I will fit all the signals, as well as I can do one thing I want in the separate Then you need to come here. I think I have covered this everything, how you want to present your right. So here you can directly go for the export as well. Here you can export. And if you want, and you see here, only selected message are come here. But again, you need to go for the settings, select your setting. This is the shortest way, but it is very smart way. The reason is you are exporting the signal which you are analyzing here, right? If I fit all the signal here, so I'm more interested in the torque and speed, then I will right click and go for the export. Very, very useful. And so here, if you want in CSV, you can go for the CSV. Let's say I'll go for the CSV. And if I say, let's say sample 2, and if I save, then let's check for this file. Only 2 signals must be exported. Let's check here. And then let's open. Something is wrong with this file. Aha, the file is not exported. I need to save. Yeah. Okay. Now I'm saving this file. And now let's open that file. File is saved. Let's open. Yeah, it's opening. Now there should be only 2 signals. Yes, there are only 2 signals. Which one is I wanted to export, right? So this is the shortest way to export. I have exported the speed and torque of the motor. So this is all about exporting. Very useful and mostly used for doing the statistics around your CAN data. And I hope you would definitely start with this learning to export the files in the different file formats. And widely used are MAT and CSV, and I explained the reason why that is widely used, because you no need to have the specific CAN analyzing tools like vehicle spy, pick tool, or any interpret tool, anything. You can just go with the Microsoft Excel, you can go with the MATLAB and do the analysis. And for your learning, that's enough for today. I would like to know always what was valuable for you inside this session. Am I really making something interesting for your learning? What was your most valuable takeaway from this session? Tell me in the comment section for a chance to be my next viewer of the week. I will see you in the next one. Thank you for your time. Please like, share, subscribe to my channel. Thank you and have a nice day ahead. Bye bye.